Hello, grade 9s. This is Mr. Kerbis and
Miss Senior.
So we're moving to the next stage of this distance learning project, and we're going to explain how to compare our initial function, which you've already submitted, right? All of them have already submitted this, and the points, right?
Okay.
So these are the actual points. You've already done that part, and we've already got our first model. So sometimes we're a bit low, and sometimes we're a bit high.
Okay. So how do we go about analyzing how different they are?
I think statisticians had lots of different ways they could have done, and for this year we're focused on what's called the absolute difference. So we'll take these blue points and subtract the function values and add up the sum of all those differences. Now here the blue points are above and here they're below. How are we going to deal with that?
Well, we're actually only interested in how far apart they are, aren't they? So the fact that it's below or above doesn't make any difference to what we are interested in. So if we take our absolute value, then it's only looking at a positive value of the difference.
Perfect. Okay, so x is our goal. We want to know not when, but I've changed it to x because I want to know where it hits the ground. And these are our starting values then. So I'm going to copy those. Now, for some crazy wacky reason, my Excel, and some of you might have this, my Excel doesn't like the period. So I have to take those values and I have to copy them into numbers. Then I have to do a find and replace all periods with commas. Okay?
Can I ask just how did you bring up that find and replace?
Oh, thank you. Command F. That's a good point.
Perfect.
So now I take these and I copy them and I paste them into Excel. And notice I've already come up with these headings here. What's the heading of this column?
So the actual ball horizontal.
Okay, 2 decimal places should be good for centimeters, right?
Yep. And so what that's saying is that's the actual x value of the data point, the actual data point that we plotted.
Okay, so you can see these values here, and as I hover over them, then at the bottom left-hand corner, you get those x values and y values, okay? So next, I want the actual ball height. So is that the blue or the black?
The actual is going to be the blue. So
Okay.
it's the data points that we've got.
All right. And it hasn't been a brilliant origin placement. Hopefully they're smarter than us, hey?
I'm sure they are.
Okay, so again, we gotta do this silly trick. You may or may not have to do this trick, but then I do a find and replace, press enter, replace all periods with commas, take that, copy it into Excel as the actual ball height. And I don't like all those decimal places, so we're gonna go number 2 decimal places and tidy it up a bit. Brilliant. Okay, so now we have the horizontal and the vertical actual locations of the ball data. And next, what's this column?
So this is the model that we think best fits, or currently our first model that fits the data points. But when we saw the actual model on LoggerPro, we can see it's not always in exactly the same point as the data points. So we are going to now be working out what the point is. So if we're looking at that this point up here, we're looking at the point on the actual function that corresponds to the same x value.
Okay, so that we can find that. Excellent. Okay, let's pull this over here. Good. So this is our first attempt. We need negative, 0. Now in my Excel I need a comma, depending on your setting. Now obviously I can't just type an x here. What am I going to place instead of that x?
So our x value for this data point is actually 0.38, isn't it?
Okay.
But we don't even need to just type in that value. We can just click on the cell and it puts it in.
So why don't we want to type 0.38 there?
Because it means that every time we would have to put in, we'd have to retype this equation every line down. But what we can actually do to make it a little bit quicker for ourselves, once we've done it for the first one, we can actually drag and drop that all the way down the column. And it doesn't mean that each cell says 2.24 now. If we click on one of these cells below, you'll notice that it's actually using the cell that corresponds to that row.
Okay, so the variable x varies as the horizontal location of the ball varies. Brilliant. Okay, absolute differences now. And again, we talked about why this and this would basically cancel each other out if we're not careful, right?
Yeah.
So we need to find the absolute value. Luckily, Excel has that built in, abs. And we are going to take this value, which is the actual ball height, and subtract the model value. And what that is finding is this distance here.
Perfect.
We'll use Miss Senior's trick of dragging. How come all these are positive?
Well, that's the neat little trick with the absolute value. It's only looking at the actual distance, not whether it's below or above. So it's just taking the positive value of the difference.
Okay. Now, we're going to do one final thing. We're going to go equals sum, open a bracket up, click on the top cell, click on the bottom cell with the shift, close the bracket, enter. What is this special number here?
So that's now added up all the differences across all the points that we've collected.
Brilliant. Okay. So, do we need a little summary here?
That's probably a good idea, isn't it? So first we need to know what our model is.
Okay.
Then we're going to be importing into Excel our x values and our y values.
So we copied these in, and we copied these in.
Yeah. And then we use these values we use the x values to predict what our model would actually say our y value should be.
Okay. Clicking on the cell to replace the x values, and then dragging down.
Yeah. Then once we've got what the model says it should be and what our data point says it should be, then we can look at the difference between the two.
Okay. Now, let's say the students are smarter than us and they came up with a better model, and their number here was 30.
Okay. That would imply that they've actually found a better model than we have. And it means it's closer than our model is to the data points.
Excellent. So, should we show them in the next video how to improve this model?
That sounds like a good idea.